All right, let's have a look at the solutions to our previous assignment. Okay, question 1, solve the inequality r squared minus 10r plus 25 greater than 0 in the real number set. All right, so in order to solve this inequality, we should consider the corresponding function, right? So we should consider the quadratic function y equals r squared minus 10r plus 25. All right. Okay, so we can sketch this function and find the corresponding interval that can make this function that is greater than 0, right? So first of all, we can convert it to the vertex form. So note here, negative 10r can be rewritten as 2 times r times negative 5, right? So this is a number we are looking for. You can try using r minus 5 squared. And if you verify this by expanding it back, you can find this expression is exactly the same with this one, right? So our transformation here is done, and we know that the vertex coordinate of the vertex is 0, is 5, 0, right? And next, in order to sketch it more accurately, we can find its y and x intercepts. So in order to find its y-intercept, we can let r be 0. If r is 0, we can put it here, right? That means y is 25. Next, we can let y be 0 to find its horizontal intercepts. Okay, so if y is 0, that means r minus 5 squared is 0. That means r is 5, right? Okay, so that means there is only one horizontal intercept. Okay, now we can sketch this function. This is our vertical axis r, horizontal axis r, r, and first of all, vertex is 5, 0. So this is 5, 0, and we know the leading coefficient is above 0, so it's opening up, right? Basically, it will have a shape like this. And the y-intercept is 0, 25. And the horizontal intercept is also the vertex here. So basically, it will have a shape like this. And then we'll find its interval that can make this function greater than 0. And apparently, from this sketch, we know that anything to the left of the vertex can make this function greater than 0. And any number that is to the right of this vertex can also make it greater than 0, right? Therefore, the solution is r is either less than 5 or r is greater than 5. Or you can also say r belongs to the whole real number set and r is not 5. This is also a correct answer, right? And also you can write it in the interval form. If you write it in interval form, you should write it like this. R belongs to negative infinity to 5, union with 5 to positive infinity. Okay, so any of these three expressions here is correct. All right, so please have a look at this question and let me know if you finish, okay?
Okay.
All right, then let's have a look at question 2. Solve the inequality 2x squared minus 12x plus 18 less than or equal to 0 in the real number set. Okay, again, the method is similar. First of all, we consider the corresponding function. Okay, but note here, first of all, we can simplify this inequality, right? Well, let's call this 1. Let's label this with 1. Apparently, the inequality 1 is equivalent to, we can divide both sides using a 2, right? Because 2 is a common factor here. If you divide both sides using a positive number, remember that we don't change the direction of the inequality symbol, right? So original inequality is equivalent to x squared minus 6x plus 9 less than or equal to 0, right? Okay, let's label this with number 2. All right, so number 2 is already simplified. So next we can consider the corresponding function. So let's consider the quadratic function y equals x squared minus 6x plus 9, right? Okay, in order to solve the inequality, we need to find an interval that can make the function less than or equal to 0, right? Therefore, it's better to sketch its graph and then find the corresponding intervals. Okay, so first of all, we need to convert it to the vertex form. So note here, x squared minus 6x plus 9 can be converted to x minus 3 squared, right? And apparently the vertex is 3, 0, and it opens up, right? Because the leading coefficient is greater than 0. Okay, next to find its y-intercept, we can let x be 0. If x is 0, we can put it here. Solve for y. Y is 9, right? Therefore, the y-intercept is 0, 9. Then we can let y be 0 in order to find its x-intercepts. So we can put it here, right? If y is 0, that means x minus 3 squared is 0. Therefore, we can solve x is actually 3. So there is only one x-intercept, which is 3, 0. And then we can sketch its graph. Okay, first of all, vertex 3, 0. Then it's opening up, right? Opening up. So basically, we'll have a shape like this. Then the y-intercept here is 9, 0, right? And the x-intercept is 3, 0, which is also the vertex. Okay, and our task is to find any interval that makes this function less than or equal to 0, right? Okay, apparently such interval exists here. Only at this point, right? Less than or equal to 0. Any other point can only make this function greater than 0, right? So there is only one solution. Therefore, the solution is x equals 3. Okay, please have a look at this question and let me know if you finish.
Okay.
Okay, then let's have a look at question 3. Again, the task is to solve a inequality. Negative x squared plus 12x minus 36 greater than 0 in the real number set. Okay, so first of all, if you don't like leading coefficient to be a negative number, of course you can always transform it by moving everything to the right side, right? We don't like a negative leading coefficient. The original inequality is equivalent to x squared minus 12x plus 36 less than 0. Again, I should say this step is not necessary, okay? You can just keep it in the original form, does not matter. Next, we can consider the corresponding function, right? So let's consider this function and then sketch its graph. Then we can find any interval that can make this function less than 0, right? Okay, next we consider this function. Y equals x squared minus 12x plus 36. Again, in order to sketch this graph, we need to find its vertex, direction of opening, y and x intercepts, right? So first of all, it's better to convert it to the vertex form. Okay, so note here the term in the middle can be factored to 2 times x times -3 and -6, right? So this is the number you should try. So let's try using x minus 6 squared. And if you expand it, you will get x squared minus 12x plus 36, right? You have introduced a extra term 36, so let's subtract it. So this expression is exactly the same with the first two terms, right? But there is another 36, so we need to plus another 36. Okay, so the original expression is transformed into the vertex form, which is x minus 6 squared, right? Okay, again, the vertex is 6, 0, right? And we know that this function opens up. I mean, this function, right? Because the leading coefficient here is 1, which is above 0, so it opens up. Therefore, next step, we can let x be 0 to find this y-intercept. If x is 0, let's put it in the original expression. That means y is 0 minus 0 plus 36, so y is 36. Therefore, the y-intercept is 0, 36, right? And next, we can find its x-intercepts by letting y be 0. Okay, if y is 0, we can put it here, right? That means if y is 0, x minus 6 squared is 0. Therefore, you can solve x is actually 6, right? Okay, that means there is only one x-intercept, which is 6, 0. Now we can sketch the graph of this function like this. Y-axis, x-axis. First, the vertex is 6, 0, which is about here, right? 6, 0. And we know it opens up. So opens up. A parabola opens up should look like this. Right. Okay, the y-intercept is 0, 36. Here. And x-intercept is the vertex, which is 6, 0, right? Okay, we are going to find any interval that is less than 0, right? Remember that we have converted the original expression into the expression here. So our task, and remember this curve is actually y equals s squared minus 12x plus 36, right? So our task is to find any interval that can make this function x squared minus 12x plus 36 less than 0. So where are the intervals? There is no such interval can make this function less than 0, right? Because as you can see in this graph, the interval on the left of the vertex can make this function greater than 0, right? And any interval to the right of the vertex can also make this function greater than 0. And at the vertex, this function is exactly 0, right? That means no interval can make this function less than 0. Therefore, there is no solution, right? No solution in R. And we can also express this in the interval form, which is X belongs to the empty set, which means there is no such X can fulfill such a inequality, right? Okay, please have a look at this question and let me know if you finish, okay?
Okay.
All right, then let's go to the next one. Okay, question 4. It's about graphing a inequality. Y equals or greater than 2x squared minus 20x plus 53. Okay, first of all, in order to graph a inequality, usually we'll consider the corresponding function, right? So first of all, let's consider this function. Okay, first of all, let's consider this function. We can let the inequality symbol be a equality symbol, which means y equals 2x squared minus 20x plus 53. This function is the boundary of this inequality area, right? So let's consider this function first. And in order to sketch the function again, first of all, it's better to convert it to the vertex form, right? Which means you can put 2 in front, and then x squared minus 10x plus 53 over 2, right? And note here, the negative 10x can be factored to 2 times x times negative 5, right? So this is a number we should consider using here. So let's try x minus 5 squared. And if you extend it, you will get x squared minus 10x plus 25, right? Because there is no 25, we need to subtract it. Then copy the rest of the expression. Then let's combine all the constants. So this is minus 50 over 2, right? Plus 53 over 2, which will get us negative 3 over 2. Oh, sorry, positive 3 over 2, right? And then we can assign this common factor 2 like this. Okay, so this expression is the vertex form, right? This is called the vertex form. And we know that the vertex coordinates of the vertex is 5, 3, right? And we also know that this function opens up, right? Because the leading coefficient is 2. So leading coefficient is greater than 0 means it opens up. Basically, we'll have a shape like this, right? Okay, next, we know the vertex, we know the direction of opening. Then we can let x be 0 to find its y-intercept. So if x is 0, it's better to put it here in the original expression, right? So if x is 0, we know y is 0 minus 0 plus 53. So y is 53. Next, we can let y be 0 to find its x-intercepts. this time it's better to put it in the converted expression, right? So that means 2 times x minus 5 squared plus 3 is 0. Therefore, x minus 5 squared is negative 3 over 2. And apparently this cannot happen, right? Because x minus 5 squared, no matter what x is, this expression is always a non-negative number. So there is no solution, no real solution, right? That means there is no x-intercepts. Okay, then we can sketch the graph. Y-axis, x-axis. First of all, the vertex is 5, 3. So suppose 5, 3 is here. Then we know it's opening up, right? So basically it will have a shape like this. And this is a y-intercept, which has a coordinate of 0, 53, right? Again, not necessarily to scale, as long as you keep the relative positions of all elements correct, you'll be fine. And there is no x-intercept, right? As shown on this graph. Okay, next. This is a boundary of the region that represents this inequality, right? Then let's consider the inequality. Actually, you need to shade any region that represents y equals or greater than, right? If y equals the right side, that means it's right on the boundary, right? And if y is greater than, that means any area that is above the boundary needs to be shaded, right? Okay, first of all, the boundary should be included in your region because y can equal to the right side. Next, we need to shade any region that is above the boundary, right? Okay, so this shaded area denotes y greater than or equal to 2x squared minus 20x plus 53. So usually we'll put the expression that stands for this area next to its graph, right? Okay, please have a look at this question and let me know if you finish.
Yeah.
Okay, then let's have a look at the solution to question 5. Again, the task is to graph the inequality y is less than negative 3x squared plus 5x minus 18. So note here, this time we don't have any equality symbol here, right? So probably we should not include a boundary. Okay, so first of all, let's consider the corresponding function. Okay, let's consider the function y equals negative 3x squared plus 15x negative 18. Okay, and again, in order to sketch this function, we need to transform it to the vertex form, right? So let's put the common factor negative 3 in front, then we have x squared minus 5x and then plus 6, right? And again, if you have a negative number in front, pay special attention to the symbols behind. And you can always verify by multiplying it back. So this expression should be exactly the same with this one. That means your first step is correct. Okay, next step. This equals Again, we have x squared here, so we should factor this to 2 times x times something, right? Apparently, -5x can be factored to 2x times -5/2, right? So this is a number. This is a number we should consider. So -3 times x minus 5/2 squared. And if you expand it, you will get x squared minus 5x plus 25/4. Because there is no 25/4 in the original expression, we need to subtract it and then copy the rest of the expression. Then let's combine the constants. So this equals -3 times x minus 5/2 squared. Then -25/4 plus 24/4. So this is -1/4, right? And then we can assign the -3 to the two terms. So this is -3 times x minus 5/2 squared and plus, right? Negative gives you plus 3/4. All right. Therefore, the vertex is 5/2, then 3/4, right? This is a vertex of this function. And we also know because the leading coefficient here is -3, so that means it opens down, right? So a quadratic function has vertex 5/2, 3/4, and opens down. Next, we find its x and y-intercepts. So we can let x be 0 to find its y-intercept. If x is 0, we put it in the original expression, right? That means y is 0 plus 0 minus 18. So y is -18. That means the y-intercept is 0, 18, right? Okay, next one. We can let y be 0 to find its x. So if y is 0, you know that -3 times x minus 5/2 squared plus 3/4 is 0, right? And this gives us x minus 5/2 squared is actually 1/4, right? Then we know x minus 5/2 is either positive or negative 1/2, right? Therefore, x is either positive 1/2 plus positive 5/2, which is 3, or x is negative 1/2 plus 5/2, which is 2, right? Okay, so we know the vertex direction, y-intercept, x-intercepts. Now we can sketch the graph. Y-axis, x-axis. And vertex is 5/2, 3/4, which is about here. And we know it's opening down, right? Whether it's opening down like this or like this, right? That depends on the y-intercepts. The y-intercept is a negative number, so this is a y-intercept, 0, -18. So that means it must cross the y-intercept as this. And there are two x-intercepts, which is 2, 0, and 3, 0, right? Okay, so that means this is a sketch of the graph of this function, right? And this function is actually the boundary of this area, right? Okay, let's get back to the inequality. Inequality says graph the area that denoted by y is less than the function on the right. So that means we should shade any area that under this curve, right? Because this curve stands for y equals the right side. And if we want to find the area that denoted by y is less than, that means we need to shade any area under this curve. And this curve cannot be included in that region because this inequality states that it is strictly less than. So first of all, we should use dotted line to indicate we do not include this boundary in our region. Next, we shade any area that is under this region. Okay, so this region here stands for y less than -3x squared plus 15x minus 18. Okay, please have a look at this question and let me know if you're finished, okay?
Okay.
All right, let's see the next one. Again, next question is about graphing the system of inequalities. The method is similar, except that this time we have two inequalities, right? So if you use a symbol like this to combine the two inequalities, that means we need to find the overlapped areas denoted by these two inequalities, right? So for the first one, y is greater than or equal to 0. If we have a 2D plane like this, y is greater than or equal to 0 is denoted by this area, right? And this is very easy to find. Our job is should focus on the second one. As long as we can find the second one, then we can find the overlap area, right? Okay. So let's say we start from the second one. Second one is a quadratic inequality. Apparently, we should consider the corresponding function, right? Okay, so let's consider the function y equals negative 5x squared, negative 30x minus 40. Okay, in order to sketch this graph, we need to convert it to a vertex form, right? So let's put the common factor of negative 5 in front. Then we have x squared plus 6x plus 8, right? And next, note here we already have x squared, so 6x can be factored to 2 times x times 3, right? So we should try number 3 here. Negative 5 times x plus 3 squared. And if you expand x plus 3 squared, you will get x squared plus 6x plus 9, right? Because there is no 9, we need to subtract it in order to make this expression equal the first two terms. Then copy the rest of the expression, which is plus 8. Then simplify this expression. This is negative 5 times x plus 3 squared, then plus 5, right? And this is the vertex form. Therefore, the coordinates of the vertex is negative 3, 5. And the direction is it opens down, right? Because the leading coefficient is negative 5. So it opens down. Next, in order to more accurately sketch it, we let x be 0 to find its y-intercept. If we let x be 0, let's insert it to the original expression. So y is negative 40. So that means the y-intercept is 0, negative 40, right? And next, we let y be 0. Let's insert it here. If y is 0, that means negative 5 times x plus 3 squared plus 5 is 0, right? And that means negative 3, negative x versus 3, x plus 3 squared is 1, right? And then we can solve x plus 3 is either positive or negative 1. Therefore, x is negative 2 or x is negative 4, right? So there are two x-intercepts, which are negative 4, 0, negative 2, 0. Okay, then we have all the information here. The vertex, direction, y-intercepts, x-intercepts. Then we can sketch a graph of the second inequality. Okay, y-axis, x-axis. And first of all, the vertex is negative 3, 5. Negative 3, 5 is probably here. Again, not necessarily to scale. And it opens down. So whether it opens down like this or like this, that depends on the y-intercept, right? Y and x-intercept. So first of all, we know the y-intercept is negative 40. So negative 40 is, let's say, it's about here, right? And both of the x-intercepts are less than 0. So it should look like this. Okay, y-intercept is here, which is 0, negative 40. And one of the x-intercepts is here, negative 4, 0. And the other one is negative 2, 0, right? Okay, so let's go back to the inequality. Inequality states that y is less than or equal to. less than or equal to. So first of all, equal to means that the boundary should be included, right? So the boundary should be included in this region. Next, any region that is less than this function, that means any region that is under this curve should be included, right? This is the region that is corresponds to the second inequality, right? Follow me? Okay, but remember that we have another one. We have another inequality, which is y is greater than or equal to. As we have discussed, y is greater than or equal to means any region that is above the x-axis, right? Can you follow me? Therefore, we should shade the overlapped area, right? Apparently, the overlapped area is here. And we should also include the boundary here. Okay, should I include the boundary here? Of course, no. Of course, yes, right? Because y can also equal to 0. So that means we should also include the boundary here. So this is actually a enclosed area denoted by the green shaded area here. Okay, therefore, the solution is the green shaded area. Okay, if you answer this in an exam, if you don't have color paints, you should use different patterns, right? You should, for example, you should use this pattern to denote one area, probably another pattern to denote another area, and of course, the overlapped area is denoted by this pattern, right? Okay, so please have a look at this question and let me know if you finish, okay? And do not forget the origin point. Oh.
Okay.
All right, let's see the next one. Again, we need to sketch the overlapped area, right? But this time we have 3 inequalities. But don't worry, can you just guess what is the overlapped area of the last 2 inequalities? I'll give you a hint. Suppose we have a 2D plane like this. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? So can you see what is the area denoted by these 2 inequalities? First, second, or third, or fourth quadrant? Which one?
Two.
2. Okay, so you think it's 2, right? In the second quadrant, so for example, this is -1, -2, -3, -3, -4. This 1.
Oh, never mind.
Okay. No? So which one is correct? 1, 2, 3, 4. So -1, -2, -3, -4.
4.
Fourth quadrant, right? Fourth quadrant is correct because in the fourth quadrant, all x's would be greater than 0 and all y's is less than 0, right? Understand? Any point in the fourth quadrant, their x coordinate is greater than 0 and their y coordinate is less than 0. This is in accordance with these two inequalities. Understand?
Yeah.
Okay. Whereas in the second quadrant, any point xy has a x coordinate less than 0, of course, and y-axis greater than 0, right? This is not stated by these two because it says x is greater than 0, y is less than 0. This is different, right? Okay, so that means the correct answer is the fourth quadrant. Okay, so it is not very difficult to find the region that corresponds to the last two inequalities. We only need to consider the first one. Then we can find the overlapped area between the first expression and the last two expressions. Okay, so for the first inequality, we can consider the corresponding function. Let's consider the function. Which function? Function is y equals -3x squared plus 12x minus 12, right? Again, in order to better sketch it, we need to transform it to the vertex form, which is -3 times x squared -4x, then plus 4, right? Okay, again, this is not easy to, and not very difficult to see. It's actually -3 times x minus 2 squared, right? And this is already in a vertex form. Therefore, the vertex of this function is 2, 0. And we also know it opens down, right? Because the leading coefficient is less than 0. Okay, next we can find its y-intercept by letting x be 0. If x is 0, let's put it into the original expression, which means y is -12. So the y-intercept is 0, -12. Next, we can let y be 0, find its x, right? If y is 0, that means -3 times x minus 2 squared is 0. Therefore, the solution is x is 2. So that means there is only one x-intercept, which is 0, 2. Then we can sketch the graph of this function. Okay, y-axis, x-axis. Graph of the first function of this function here. First of all, vertex is 2, 0. So 2, 0. So let's suppose 2, 0 is here. Then we know that it opens down, right? Okay. So the y-intercept is 0, -12. So let's mark it here. And x-intercept is just the vertex here, which is 2, 0. Okay, next one. Remember, we need to sketch the area that corresponds to the inequality, right? The inequality states that y is above this curve. That means any region that is above this curve is the area we want. Actually, it's this area, right? You understand? Can you hear me?
Yeah.
Okay, any area above this curve is denoted by the first inequality, right? And of course, we should not include the boundary because this is a strictly greater than. Okay, so this boundary overlapped with the fourth quadrant. Can you find the area? Because we have already analyzed, this is the first quadrant, right? X greater than 0 should be on this side. Y less than 0 should be on this side, right? If you consider all three areas, what's the overlapped area? Can you find it on the graph?
Bottom.
It should be here, right? Can you see that?
Yeah.
Okay. Let's use a different color. Okay, y is greater than 0. That means the whole right side of this y-axis. Y is less than 0 means the whole area here, right? Do not forget, you should also consider the first one. That means any region that is above this curve. Of course, this is the overlapped area, right? Okay, let's make it clear. Let's erase all this. Then let's mark the quad area. First of all, the boundaries cannot be included, right? Because any of these three inequalities states that strictly greater than or strictly less than. So we should not include the boundary. And then we already analyzed that this shaded area is the overlapped area, right? So if we call this system 1, and say this area corresponds to system 1, okay? Okay, so please have a look at this question and let me know if you finish. All right, then let's have a look at the next one. Okay, it is given that k is some real constant. That means k is a real number and it's constant, right? For what number of what values of k the inequality has the solution x belongs to the real number set. Okay, in other words, any arbitrary real number can make this inequality hold. Okay, so first of all, let's consider the corresponding functions. Left side is apparently a quadratic function, right? So let's consider this function. Consider the quadratic function on the left. Y equals -3x squared plus 6x plus k, right? Okay, so the leading coefficient is a negative number, right? Negative number means it opens down, right? And there can be only 3 cases in terms of the relationship between this curve and the x-axis, right? So first of all, it can have no x-intercept. Second, it can have only one x-intercept, right? And third, it can have 2 different x-intercepts, right? And the question states that any real number can make this function less than 0. That means no matter what x is, this function is always less than 0, right? So that corresponds to the first case, right? In the first case, as you can see here, no matter what x is, this curve is always under the x-axis. That means no matter what x is, the function is always less than 0, right? You understand? Can you follow me? Hello?
Mm,
If you don't
it's,
understand, you can just ask your question. I want to make sure you understand what I'm talking about.
no, yeah, I understand.
No?
No, I understand.
No what? Excuse me?
I understand.
Okay. Okay, that's good. And we have discussed only the first case, in only the first case, no matter what x is, this function is always less than 0. Okay, so that means if we let -3 x squared plus 6x plus k be 0, there will be no solution, right? Because we are trying to find the zeros. Let's add another statement here. Therefore, 1 has no zeros. Zeros or X-intercept. You could use either terms here. Okay, so if we let this expression be 0, there will be no solutions, right? Therefore, in which situation there will be no solutions to this quadratic equation? We need to discuss the determinant, right? Determinant is delta, right? Therefore, delta is less than 0. Therefore, what is delta? Delta is b squared minus 4 by a is -3, by c is k. This must be less than 0, right? So that means 36 plus 12k should be less than 0. Therefore, 12k should be less than -36. Therefore, k needs to be less than -3, right? You understand?
Yeah.
And this is our final solution. Okay. Please have a look at this question and let me know if we can move on.
Okay.
All right, let's see question 9. Gain k some real constant for what values of k, the inequality here has no real solution. Okay, so first of all, let's consider the corresponding function on the left side. If we consider this function, all right, first of all, let's move everything to the left or right, okay? Because we need to convert it to the general form. So first of all, let's move everything to the left. So expression number 1 is equivalent to x squared minus 9x plus 10 minus k less than 0, right? And then we can consider the function on the left side. That means consider function y equals x squared minus 9x plus 10 minus k. And apparently this is a quadratic function, right? This quadratic function is less than 0, no matter is less than 0 at no real number, right? That means no real number can make this function less than 0, right? Okay, so first of all, let's consider the sketch of this function. This function is apparently opening up, right? Opening up, and there are 3 relationships between this curve and the x-axis. First of all, it can have no x-intercepts, right? Okay, opens up, no x-intercepts, first case. Second case, x-axis is still here, but this time this function has only one x-intercept. And next case, x-axis is here. This function can have 2 different x-intercepts, right? So in which case, no x can make this function less than 0. Can you see that? Which one? A, B, or C? No x can make this function less than 0. That means all x can make this function greater than or equal to 0, but not less than 0, right? Which is a correct case? Can you hear me?
Yeah.
Which is a possible case?
Let's see.
See why?
Because it could be less than 0.
Okay, can this x here make this function less than 0 if x is here?
Yes.
Yes, that means there exists an x can make this happen, right? But the question states that this inequality has no real solution. That means there is no x can make this inequality hold.
No, A and B.
So that means the only case that is correct is A or B, right? Because in case A or B, no matter what x is, the function is always greater than or equal to 0, right? That means if we let the function be less than 0, there will be no real solution. Okay, so that means the function 2 has 0 or 1 x-intercept, right? If it has only 0 or 1 x-intercept, that means if we let this function be 0, there is only 1 or 0 solution, right? Okay, apparently this is a quadratic equation. In which circumstance there is only 1 or 0 solution? That depends on the value of delta, right? Can you follow me? Either delta is greater than 0, equals 0, or less than 0. Which one is correct? If there is only 1 or 0 solution to this quadratic equation, which one is correct? Okay, let me ask you. If delta is greater than 0, what will happen?
Then it's real.
there will be two solutions, right? Two different solutions, right? And if delta is 0, what will happen?
And there's one.
Only one solution, or it's called a double solution, right? Okay, and if delta is less than 0, what will happen? For a quadratic function like this, if delta is less than 0, what will happen?
There's no solution.
There will be no solution, okay? And we already know that this function is only has only one or zero solution, right? Therefore, our delta here needs to be either this one or this one, right? You understand?
Yeah.
Okay, let's calculate the delta. Delta is b squared, which is 81 minus 4ac, 4 by 1 by 10 minus k, right? And we have already know that delta needs to be either less than 0 or equal to 0, which means 81 minus 40 plus 4k needs to be less than or equal to 0, right? Therefore, 4k needs to be less than or equal to negative 41. Therefore, k needs to be less than or equal to negative 41 over 4, right? Okay, please have a look at this question and let me know if you finish.
Okay.
Okay, let's see the next one. Okay, this time k is some real constant. For what values k, the inequality like this has only one real solution. Okay, so in order to find the solutions, we need to discuss different values of k, right? Because this expression here is not necessarily a quadratic function, right? First of all, let's say if k is 0, what will happen? If k is 0, let's say this is number 1. 1 is equivalent to negative x, negative 1, greater than or equal to 0, right? And how many solutions are there to this inequality? Can you tell me? How many solutions are there?
Infinite.
There'll be infinite number of solutions, right? Because any number that is less than or equal to negative 1 can fulfill this inequality, such as x can be negative 1.5, can be negative 2, can be negative 200, can be negative 1000, can be negative 10 to the power of 6, right? There are infinite number of solutions to this inequality. That's obviously contradictory to the expression in the question, right? Because question states that the inequality has only one real solution. Therefore, okay, therefore when k is 0, it has unlimited solutions. This is apparently not coincide with what the question states. So k cannot be 0. And if let's discuss what will happen if k is not 0. apparently if k is not 0, the left side is a quadratic function, right? And whether it's opening up or down depends on the value of k. So second, we should discuss if k is greater than 0, what will happen? Then if k is greater than 0, let's consider the function y equals kx squared minus x minus 1. And apparently it opens up, right? Because leading coefficient is greater than 0, so it opens up. Okay, if it opens up, it will have a shape like this, right? So it will have 3 different kinds of relationship with x-axis, whether it has no zeros or just 1 0, or it can also have 2 zeros, right? Depends on different values of k. And note here, the question states that this inequality has only one real solution. That means there is exactly one value of x can make this function equals 0, right? So are these possible in these 3 different cases? Okay, let's consider them one by one. In the first case, how many solutions are there to make this function greater than or equal to 0? How many solutions are there?
1.
Which one?
2.
Why?
1. The first.
I mean, in the first case, how many solutions are there for this?
Infinite.
Infinite, right? Okay. So this cannot be the case, right? Because the question states that this inequality has only one real solution, so it cannot be the case. How about the second one? How many number of solutions are there?
Unlimited.
Also unlimited, right? Because all of these numbers can make this function greater than or equal to 0, right? So it also has unlimited number of solutions. So it cannot be the case. How about the second one? How about the third one? How many solutions to the inequality this function is greater than or equal to 0? How many solutions are there? So any point that is to the left of this 0 and any point to the left, to the right of this 0 can fulfill this inequality, right? So how many solutions are there that can make this function greater than or equal to 0?
Unlimited.
Also unlimited, right? So also unlimited number of solutions. So this cannot be the case. Therefore, k cannot be greater than 0, right? Therefore, you can make this conclusion when k is greater than 0, there are unlimited number of solutions to rational expression, right? Okay, that's a discussion for k is greater than 0. So third case is, how about if k is less than 0? Let's discuss if k is less than 0, what will happen? Okay, if k is less than 0, also consider the function y equals k x squared minus x minus 1. And we know k is less than 0, so it opens down, right? Okay, because it opens down, we'll have a shape like this. And probably there is no x-axis. or only one x-axis, right? And can also have two x-axis, right? Okay, so let's see what will happen in different cases. Okay, remember, we are considering the solution to kx squared minus x minus 1 greater than or equal to 0, right? So in the first case, how many solutions to this inequality? That means how many number of x's can make this function greater than or equal to 0? You see that?
None.
0, right? There is no x can make this function greater than or equal to 0 because all the values of the function is under the x-axis. So no matter what x is, this function is always less than 0, right? How about the second case? How many points, how many x's can make this function equal to or greater than 0? As x
0.
moves along, how many?
0.
As x moves along the x-axis, is there any x that can make this function equal to or greater than 0? Are there
Yes.
such x's?
One.
Only this point, right? Only at this point, this function is greater than or equal to 0, right? So there is one solution. How about this point? How about this case? As x moves along the x-axis, how many x's can make this function greater than or equal to 0? How many solutions are there? Unlimited number, right? Because any number that is fall within this interval can make this inequality hold, right? Any x that is within this interval can make this function above or equal to 0. You understand?
Yeah.
Okay, so which situation is a possible situation? Apparently, only this situation, right? Because the question states that this inequality has only one real solution. That means only in this situation, we have only one real solution, right? Okay, so according to our discussion here, this function, let's call it number 2. Number 2 only has 1, 0, right? Or X-intercept. So we can let kx squared minus x minus 1 be 0. And there is only one solution, right? If there is only one solution, that means what is our delta? Can you tell me what is the delta? Delta is greater than 0, equals 0, or less than 0. Which one is correct?
Equal to 0.
Equal to 0, right? Because only only if delta is 0, there is only one solution. That means b squared minus 4 by a by c is 0, which means 1 plus 4k is 0, which means k is negative 1 over 4, right? Okay, so please have a look at this problem. Let me know if you finish.